RePOSE, 3D human estimation were spatial and temporal diff relational consistency. This paper was published in ECCV 2024. So the motivation of this paper is to build a 3D human pose estimation which provide a good performance in occluded scenario. So traditional measure might struggle with occlusion due to their strongly depends on the absolute depth signals. For example, you can see here the estimate key point of the absolute depend 3D estimation method might produce this kind of estimation, but actually there is only one of the key point that is correct because they only relies on the absolute diff. But if they as they don't take the consideration on the relational diff of the post topology. So the method is proposed to taking into the account of relative depth relation between one key point with the other key points during the training for the noisy 2D as the input, like the occluded scenario. So as the goal to improve the performance on the occluded key point scenario, they move the focus from absolute diff to relational diff consistency by providing two innovative diff consistency method to provide a learning pathway for occluded key point rather than focus on the absolutely diff values. So their contribution are the spatial and temporal relational diff consistency, which they focus on the correct of the host topology using a relative diff consistency loss for both spatial and temporal domains. And the idea is simple and straightforward, and they can enhance the robustness, especially in the occluded environments. So RePOSE is proposed by using a 2D to 3D leveling outline with the goal to estimate the 3D human pose sequence from a sequential of a 2D pose as input. So it takes the 2D pose from a 2D pre-trained 2D estimator to get the 2D key point and along with the confidence score. And the output of the network is the 3D sequential of a human pose. So, however, with the 2D to 3D leveling outline, they might encounter the problem of a multiple 3D key point estimation that match into the exactly same 2D key point. This is happen because of the relies on the absolute depth and the input is missing. It means that in the occluded environments. So the core idea of this network is to move the focus from the absolute depth to the relational depth consistency by introducing two kind of depth consistency, the spatial and the temporal, to enhance the robustness, especially in the occluded scenarios. So the spatial loss is proposed to ensure that the relational depth consistency between joint within a single frames and the temporal loss is proposed to maintain the relative depth consistency of the joint across the frames. So normally, mean per joint position error is the most simple and popular loss function that is used in 3D human pose estimation because it provides a effectiveness and simple. As you can see, the formula, they only calculate the 3D key point between the estimated 3D with human pose with the ground truth. So the J and T are the number of key points and frames. And however, for the occluded scenario, this kind of the loss function might not be effective as they only consider the absolute diff without focus on relational diff, which means that when a key point is occluded, uh, there, if we consider on the relative diff consistency, we can estimate more accurate 3D key point. And however, it also doesn't consider on the temporal consistency. So the proposed network can be seen as here. It leverage the spatial and temporal transformer to capture both spatial and temporal information. For the spatial transformer encoder, this treat the it joined as a token to learn the interjoint relationship within a single frame, and the temporal transformer encoding module. It is used to model the dependencies of each joint across a multiple frames. And as you can see here, you take the video images as input, and with the help of the pre-trained 2D estimator, it produces a 2D post sequence and then send into the spatial and temporal transformer to capture the spatial and temporal information. And the rejection head is used to get the 3D pose of a video in a sequence. And during the training, this estimated through a 3D human pose will be sent to the temporal and the spatial module to maintain the relationship between joint with a single frame as well as the consistency between frame to frame. For the newly proposed spatial relational diff consistency loss, it is proposed to maintain the accurate diff relationship between joint with a single frame. As you can see here, it is the sum of the panelite between the ground between the estimated key point I with the key point J according to the condition in the ground truth. So let's say in the ground truth that the depth of the key point I is closer to the camera than the key point J. So in this case, if the estimated depth between I and J doesn't meet this condition, so the penalty will be happens. So within this mechanism, they can reduce the post estimation in consistency from the absolute diff reduction. For the temporal relational diff consistency loss, they ensure that the smoothness and consistency in the post estimation across the frames. So the evaluation, the diff reduction of the same joint across the consequential frame, and they use the diff ranking as to specify that one joint in one frame should remain consistent among the frame unless there is a valid reason like the movement or something else. So if they don't meet the condition like that, there's a penalties. So as you can see in the formula here, the J is the drawing of a key point, and J is the depth of the key point J in frame arm, and the uh, and J is the depth of the key point J in the frame arms. And this one is the estimated depth of key point J in frame arm, and this is the depth of the key point J, the estimated depth of key point J in the frame arms. So if in the ground truth, the depth of the key point J in frame arm is closer to the camera than the key point J in the frame arm, this also happen the same. So for the training, they use the standard MPJ PE loss along with the two proposed loss functions to deal with the occluded challenge. So they conduct the training and evaluation on both two data sets, the human 3.6M and the MPI 3DPH dataset. And these are the metric that they use to evaluate their performance. So this table provide the quantitative result on the 3D human 3.6M dataset. For the MPJPE and the PA-MPJPE. And T is denoted as the number of frames. And the underline here is highlight for the second best result, and the bold is highlight for the best result. As we can see with the comparison with the previous state-of-the-art method, RePOSE can perform best among all the actions. And these are the quantitative results on the MPI dataset with the other previous state-of-the-art measures, and we can see that they can achieve the best MPJPE score among the other methods. And to evaluate the generalize of the proposed loss modules, they also did it on the 3D, the human 3.6M dataset with the previous method. They only take the pre-trained model and then they fine-tune it with the two spatial and temporal relational consistency laws. And this table shows that by fine-tuning the pre-trained models with the default configuration, they can perform better than the previous result. This is the qualitative result by comparing the RePOSE with on the human 3.6M and MPI dataset. And the result so that in the occluded case, it can get a better result, which the previous method failed to estimate in the occluded scenarios. So in conclusion, RePOSE is proposed to address the challenge of the occluded through the innovative loss function, which mainly focus on relative consistency, and they also perform well for the consistent temporal consistency. Thank you.